On the night of the 21st of July 2025, the Hubble Space Telescope caught something it wasn't supposed to. See a flare of movement wrapped in a shroud of dust, like a pulse fired from the outer dark. The image arrived in fragments, static, silence, then a cocoon forming around a streak that shouldn't have been there at all. Within hours, observatories from Chile to Hawaii confirmed the same anomaly. 3I Atlas, the interstellar object first logged on July 1, had shifted course. Not drifted. Shifted. Its speed increased by a measurable margin, its tail thickened, its orbit bent, as if something inside it had woken up. Data streams filled with raw numbers that felt more like messages than measurements. A burst of light, then a faint emission of gas, timed almost too precisely to be coincidence. By dawn, the word attack started circulating through encrypted astronomer channels not as panic, but as hypothesis. What if this wasn't a natural outgassing? What if the acceleration wasn't random? The math showed intent where there should have been entropy. Hyperbolic trajectories rarely turn, yet 3I Atlas had done exactly that. Something had changed its direction, as if aligning to a distant coordinate, a point somewhere deep inside our own system. It wasn't aiming for us, not yet. But the sky had shifted, and with it, the uneasy realization that maybe, for the first time, the universe had moved toward us. Tonight, we embark on a new journey, where the theme of 3I Atlas may have just launched its first attack appears not only as a scientific phenomenon, but also as a question that challenges our imagination. If you enjoy this kind of quiet, long-form storytelling, if it helps you relax at the end of a noisy day, take a moment to like the video and subscribe, but only if this space truly brings you peace. Before we dive in, I'd love to know the sky you're watching under, what city or countryside, what weather, what glow or darkness keeps you company right now. It's always fascinating to see who's joining us from all around the world. So here is what we're watching. On the 1st of July 2025, 3I Atlas entered our registers with a hyperbolic track, a declaration that it isn't here to stay, bending around the sun but never to be held by it. That alone would be cause for 1,000 papers, yet the following weeks brought a second surprise, a measurable shift, a suggestion of extra push, as if jets hidden beneath a shell were nudging its course into something sharper. By July 21, eyes turned to space-based images and returned with frames of a thickening sheath, a hazy cocoon of dust and gas, not just a delicate streamer, but a structure, a living aura around a silent core. None of this proves motive, of course. Space is a patient sculptor, and sublimation, fragmentation, and sunlight pressure can perform magic that looks like agency. But when a visitor accelerates, when its path stiffens against the sun's pull, when its envelope grows like armor or like atmosphere, we're permitted to wonder. We'll consider whether the target is anything at all: Earth, a planet, a magnetic field, or simply our attention, then follow the mathematics of an open orbit that turns more decisively than any familiar stone. And from there, we'll step softly into the question that opened so many late-night messages and unblinking watches at the eyepiece. What exactly do we mean by attack? In a moment, we'll open that door carefully to explore the first hypothesis, that 3I Atlas has just initiated a surprising, deliberate act within our solar system. The term attack arrives laden with terrestrial connotations, with the visceral imagery of projectiles and explosions. Yet, when applied to the interstellar object designated 3I Atlas, we must divorce the word from its anthropocentric roots and consider it through the lens of pure physics. An attack, in this context, may not be an act of malice, but a sequence of physical phenomena, a sudden acceleration, a controlled eruption of volatiles, a precise manipulation of gravitational fields that we, from our limited vantage point, can only interpret as a deliberate, active behavior within the inner solar system. It is a narrative we impose upon a cascade of data that resists simpler classification. Could our very language be a barrier to understanding a process that is, by its nature, entirely alien? According to current models, the initial detection of 3I Atlas on the 1st of July, 2025, placed it firmly within the class of hyperbolic interstellar objects. Its open orbit, a stark arc against the closed loops of our native system, was its most defining feature. Mainstream science suggests its high velocity is a simple relic of its interstellar journey, a fingerprint of the gravitational slingshots and cosmic currents that propelled it across the light years. The subsequent observations in late July, which hinted at a faint coma of dust and gas, could be explained by the passive sublimation of ices as the object was warmed by the sun, a commonplace cometary activity, albeit on a visitor from another star. But that does not account for the anomalous energy signature embedded within its trajectory. The object's velocity, at such a vast distance from the sun, suggests an energy budget that is difficult to reconcile with a purely passive ballistic origin. This discrepancy forces us to entertain a more speculative hypothesis, that upon entering the inner system, 3I Atlas activated a pre-programmed command packet. This could be a test of local field conditions, or the emission of a low-level energy signal designed to scan and map planetary-scale infrastructure. From the magnetospheres of the gas giants to the very corona of our Sunday, what if we are not witnessing a passive drift, but a deliberate, probing attack? To comprehend the scope of such an event, we must analyze it across multiple scales. On the microscopic level, the attack could manifest as the impact of engineered particles upon the plasma environment of the heliosphere, creating subtle ripples in the solar wind. On the mesoscopic scale, the object's minor orbital adjustments, perhaps through interactions with gravitational keyholes, could be interpreted not as random drift, but as a tactical maneuver, a calculated move on a solar system-sized chessboard. And on the macroscopic scale, this could represent the deployment phase of a test energy field, one that subtly influences the flux of the solar wind itself. Is the entire inner solar system now the substrate for an experiment we are only beginning to detect? The implications of a probing attack are dual-edged, presenting both profound risk and unprecedented opportunity. The risk lies in the potential for space weather anomalies, in the subtle perturbations of the near-Earth environment that could disrupt the delicate infrastructure of our modern technological civilization. Yet, the opportunity is a scientist's dream, a natural experiment of unparalleled scope. The passage of 3I Atlas provides a unique probe into the complex interactions of dust, plasma, and energy fields, offering data that could validate or dismantle our models as we contemplate the expansion of an interplanetary infrastructure of our own. But are we equipped to distinguish between a natural experiment and an intentional one? This very question becomes all the more pressing as we turn to the latest tracking data, which suggests a development that challenges all our initial assumptions. The steady, predictable arc we first plotted seems to be shifting, the object's velocity profile hinting at forces we have not yet accounted for. The calm narrative of a passive visitor is fracturing, giving way to a more dynamic and unsettling possibility. What if the initial probe was merely a prelude, and the true signature of its passage is only now beginning to reveal itself through a change in its very motion through the void? The latest tracking data from the global network of observatories presents a subtle but persistent anomaly in the trajectory of the interstellar object, designated 3I Atlas. It is not merely following a predictable arc dictated by the sun's gravity, it is deviating. According to current models, the most plausible explanation for such non-gravitational acceleration is outgassing the sublimation of volatile ices heated by the sun, creating a natural jet propulsion system. This is a well-documented phenomenon in comets native to our own solar system, a gentle nudge from the silent breath of vaporizing compounds. The data from the 1st of July, 2025, aligns with this, showing minor perturbations consistent with a small, icy body venting its essence into the void. Yet, the object's hyperbolic orbit and immense velocity already mark it as unbound, a free-flying entity not shackled to any star. Could such a simple, almost mundane process truly be the sole author of its path? But what if this outgassing is not a passive random event, but a controlled release? The speculative hypothesis emerges that we are not witnessing a comet, but a craft employing a sophisticated, low-technology maneuver. Imagine a sail, not of reflective mylar as we have conceived, but a dynamic, self-replenishing sail of dust and gas. This cloud, shaped and manipulated by the relentless pressure of stellar radiation, could create the precise illusion of active acceleration. It is a form of celestial sailing, using the most abundant forces in the galaxy, light and matter, as both engine and rudder. The observed deviations, those minute changes in trajectory, could then be interpreted not as symptoms of decay, but as signatures of tactical navigation. Is the object merely drifting, or is it steering? This line of inquiry compels a deeper analysis, a stratification of possibilities that escalate in their implications. The first level is one of fine-tuned navigation, a change of a mere millidegree in attitude, a subtle feathering of this dust-gas sail, could allow the object to tack across the solar wind, sliding from one magnetic field lane to another with minimal energy expenditure. It is a whisper of thrust applied with surgical precision. The second level suggests evasive maneuvering. The complex and turbulent regions of the heliosphere, where solar wind pressure intensifies, could be perceived not as obstacles, but as hazards to be avoided. Could the object's minor course corrections be a form of silent running, a way to navigate through the solar system's natural defenses, as a submarine might slip through sonar nets? The third, and most profound level, is that of strategic acceleration. By selectively exposing volatile ices to solar heat at calculated points along its trajectory, the object could be performing a series of controlled bursts, using evaporative jets to add or subtract velocity in a deliberate pattern. It would be a form of gravitational and radiative slingshot, a way to harness our sun's energy for its own inscrutable purposes. This transforms the object from a passive wanderer into an active participant in its journey. Are we observing a natural phenomenon or a calculated approach? The consequences of this hypothesis are as far-reaching as they are unsettling. For our own future in interstellar travel, the concept of a radiation pressure-driven sail presents an elegant and economical means of propulsion. If 3i Atlas is indeed employing such a technique, it offers a masterclass in low-energy cosmic mobility. Humanity could learn to borrow the gentle, ceaseless push of starlight to navigate the great ocean between stars. Yet, this very elegance carries a darker corollary. The same technology that enables cheap, long-distance travel also enables stealth. A vessel that can maneuver so subtly, using natural phenomena as its cloak, could approach a planetary system with minimal detectable signature, its intentions masked by the brilliant background noise of its own star. What does it mean for our place in the cosmos, if the most advanced technology is also the most silent? And as we ponder the nature of its motion, our gaze is drawn to the object's changing form, a development captured by the Hubble Space Telescope on the 21st of July, 2025. A new structure has emerged, not just a jet or a burst, but a full cocoon of dust and gas now enveloping the core of 3i Atlas. This growing shroud, this developing tail, is far more complex than a simple cometary coma. It appears structured, almost protective. Is this the inevitable shedding of material from an object under stress, or is it the deliberate deployment of a screen, a cloud of matter released not for propulsion, but for concealment, or perhaps for something else entirely? The object designated 3i Atlas presents a celestial paradox, a visitor whose very nature seems to shift with our perspective. Its developing dust and gas cocoon, captured in exquisite detail by the Hubble Space Telescope on the 21st of July, 2025, is a phenomenon both protective and potentially aggressive. According to current models of interstellar cometary behavior, such a coma and tail are the expected results of solar heating. As ices sublimate from the nucleus, they carry with them a cloud of dust and gas, a shroud that both conceals the core and streams away under the relentless pressure of the solar wind. The observed morphological variations in the tail's structure align perfectly with known interactions with the interplanetary magnetic field and the variable intensity of solar radiation pressure. This is the established narrative, a tale of a passive, icy body responding predictably to its new stellar environment. But what if this apparent passivity is a carefully engineered deception, a veil drawn across a more profound and unsettling activity? This leads us to a more speculative hypothesis. Could this dust and gas be more than simple debris? Imagine if the particles being released are not random silicates and frozen volatiles, but a sophisticated, purpose-sewn chaff of nanoscale conductive dust. Such a material, if intelligently deployed, would not merely drift aimlessly. It could be designed to interact with the local magnetic environment in a profoundly manipulative way. The mainstream explanation sees a coma. The speculative view posits a tool. This cloud of engineered particles could act as a form of soft breach technology, its purpose to confuse and reconfigure the natural magnetic fields that permeate our solar system. By creating a localized plasma instability, this dust could, in theory, pry open a temporary corridor, a pathway of lowered magnetic resistance through the heliosphere's defenses. The coma, then, is not a shield, but a spear. Is the object merely passing through our system, or is it actively preparing the ground for its passage? To understand the potential of such an idea, we must analyze its implications across multiple scales. At the microscopic level, a sudden, localized increase in the density of conductive particles would significantly enhance the scattering and absorption of specific electromagnetic wavelengths. This would not be a uniform opacity, but a selective filtering, perhaps blinding certain of our observational instruments while leaving others unaffected, creating a data void where something could remain hidden. At the mesoscopic level, this expanding cloud of interference would create a persistent, elongated smudge across our navigational charts. The minute positional calculations required for deep space probe trajectories would be thrown into disarray by this artificial, drifting nebula, introducing errors where once there was only the predictable emptiness of space. And on the macroscopic scale, the most profound consequence emerges: the establishment of a vast, dusty shield. This is not a shield against physical impact, but against information. Radio waves, the lifeblood of interplanetary communication, would be attenuated, their signals scattered and weakened as they pass through this newly formed, artificial medium. Could the true function of this dust be not to hide the object from our eyes, but to isolate us from each other? The selective consequences of such an event force a re-evaluation of our own technological vulnerabilities and resilience. The immediate risk is clear: a form of dust weather could systematically degrade the bandwidth of the deep space network, crippling our ability to command our robotic emissaries and receive their data from the outer solar system. The very infrastructure of our celestial civilization would be under a silent, passive assault. Yet, within this challenge lies an opportunity. The necessity to develop dust-hardened sensors and noise-resistant communication protocols would be thrust upon us, accelerating our own technological evolution in response to an external stimulus. This confrontation, whether intentional or merely a side effect of the object's passage, would serve as a brutal but effective test of our system's robustness. Will we find our networks severed, or will we learn to speak through the static? This entire line of inquiry, however, rests upon a single, foundational assumption that the actions we are witnessing are, in fact, actions at all. We have observed a dust cloud and extrapolated a potential for manipulation, for a soft, systemic attack. But to what end? If 3I Atlas is indeed acting with purpose, then its target remains the ultimate, haunting unknown. Is its goal the solar system as a whole, a vast resource to be tapped? Is it our Earth, with its uniquely rich biosphere? Or is this entire display not an attack, but something else entirely, a mere byproduct of its exotic propulsion, a cosmic sideshow, or a message we lack the context to understand? The nature of the dust may hint at a method, but it reveals nothing of the intent. The veil of particles obscures not just the object's core, but its ultimate destination and desire. If the trajectory of the object designated 3I Atlas was indeed a form of action, a deliberate maneuver through our stellar neighborhood, then we must confront the unsettling question of its objective. The conventional narrative of an interstellar vagrant, a mere mountain of ice and rock tumbling through the void, provides a comforting, if incomplete, explanation. But if we entertain the possibility of intent, the target of such a passage becomes the central mystery. Was it our sun, the gravitational anchor of our system? Was it our fragile blue world, teeming with the signatures of life? Or was it something far more abstract, a performance staged in the cosmic arena for an audience we cannot yet perceive? The true target may not have been a planet at all, but the invisible fabric of forces that binds them. Mainstream planetary science would direct our gaze to the complex interplay of gravity and momentum. An object on a hyperbolic trajectory, by definition, possesses a velocity greater than the local escape velocity of the sunday. It is a one-way traveler, a visitor from the galactic tide, and its path is dictated by the gravitational pull of every body it passes. According to current models, the slight, non-gravitational accelerations observed, the subtle pushes and pulls that cannot be attributed to gravity alone, are likely the result of outgassing. As the object's volatile ices were heated by the sun, they would vaporize, jetting from the surface like miniature thrusters, subtly altering its course. This is a well-documented phenomenon, with comets originating from our own Oort cloud. The increasing coma and tail activity as 3I Atlas plunged into the inner system is precisely what we would expect from a conventional comet undergoing solar heating. Its close approaches to the gas giants could then be seen as mere gravitational perturbations, a complex but natural billiard shot on a galactic scale. Yet, that explanation rests on the assumption that the coma was a passive, natural phenomenon. What if the outgassing was not merely a reaction, but an action? The speculative hypothesis presents a more arresting notion that the passage of 3I Atlas was a calibrated test, a technological demonstration before a departure into the dark. Its objective was not conquest, but calibration, to measure the response of our system's various plasma and magnetic environments. It used the solar wind, the magnetosphere of Earth, and the immense roaring magnetic field of Jupiter as three distinct and progressively more powerful testbeds. The timing of its planetary close approaches provided perfect, natural windows to conduct these measurements. Each encounter was an opportunity to fire a probe, metaphorically speaking, into a different type of cosmic weather and record the echo. Could a simple ball of ice and dust execute such a precise, multi-stage environmental survey? This line of inquiry forces us to consider the operation on multiple levels of sophistication. The first, and most benign, is that of a selective warning beacon. The object's trajectory was not aimed at a specific planet, but was a general broadcast into the system. Its very presence, its anomalous nature, and its high-speed transit through the orbital planes of the planets served as a universal signal, a rune carved into the geometry of space itself. It announced a capability for interstellar travel without the need for direct contact or aggression. What message is more fundamental than the demonstration of a path? The second level suggests a more active and inquisitive purpose: inter-environmental testing. The object did not merely pass through the system, it sequenced its passage through radically different plasma regimes. First, it encountered the supersonic flow of the solar wind in the outer system. Then, it skimmed the protective magnetic bubble of Earth, a relatively small and ordered field. Finally, it plunged through the Jovian magnetosphere, a plasma torus of such ferocity that it constitutes a miniature star system in its own right. At each stage, the object's coma and tail activity intensified, as if it were actively engaging with these environments, using its own dust and plasma emissions as a probe to map the local conditions. The data returned would be invaluable for any entity seeking to understand the navigational hazards and energy potentials of a new star system. The third, and most profound, level of interpretation is that of a deterrence protocol. The object was not just testing the environment, it was demonstrating a capacity to manipulate it. By controlling its outgassing and dust emission with a precision we cannot replicate, it may have been showcasing an ability to shape plasma and dust on a planetary scale. The magnificent and artificially enhanced tail was not just for measurement, it was a banner, a display of power over the very medium of interplanetary space. It showed that the traveler could, if it wished, potentially influence solar weather, disrupt planetary magnetospheres, or harness the energy of a gas giant's radiation belts. The demonstration was a silent statement: the forces that shape your system can also be shaped by a will other than your stars. What defensive preparations could possibly be mounted against a technology that treats the fabric of space as its instrument? The immediate, tangible consequence of this event, regardless of its ultimate origin, has been a dramatic shift in our own strategic outlook. The vulnerability of our technologically dependent civilization was laid bare. A more malevolent object, or a more deliberately targeted one, could use such plasma manipulation capabilities to induce catastrophic geomagnetic storms, crippling global power grids and communication networks for years. In response, the major space agencies have accelerated plans for a planetary-scale early warning system, a solar system-wide weather network. This proposed network would be a belt of sensors stationed at Lagrange points in orbit around Earth and Mars, and even as far out as the orbit of Jupiter, designed to detect the slightest anomaly in the solar wind, in planetary magnetic fields, or in the background flux of cosmic radiation. Its purpose is twofold: to provide advance warning of natural solar storms, and to act as a tripwire for any future anomalous visitors. It is a shield forged from paranoia and prudence, a testament to the fact that we are now watching the darkness with a new and more wary eye. But if a future visitor can manipulate the very medium these sensors are designed to monitor, can we ever truly trust the data they return? The entire premise of a targeted demonstration, however, rests upon one foundational and deeply anomalous characteristic of 3I Atlas: its path. A natural object, tugged by the galaxy's tides, would be expected to follow a loosely bound elliptical orbit or a simple, open-ended hyperbolic one. Yet the trajectory refined by observatories across the globe in the days following its discovery on the 1st of July, 2025, revealed something far more complex. It was not merely a hyperbolic arc, it was an arc that seemed to possess a will of its own, altering its course with a confidence and energy that defied all conventional cometary behavior. The outgassing hypothesis, while comforting, begins to strain under the magnitude of the observed non-gravitational forces. This was not the gentle nudge of vaporizing ice. This was the precise application of thrust, a series of course corrections that transformed a random interstellar passage into a deliberate tour of the system's most dynamically interesting regions. The object did not just fall through our system, it navigated it. And so we are compelled to ask, what manner of object possesses an engine that leaves no visible exhaust, and a will that can bend the laws of celestial mechanics as we understand them? The trajectory of the object designated 3I Atlas is not merely a line drawn through the void. It is a statement, a curve of motion that defies the gentle, predictable ellipses of the native solar system. Its path is hyperbolic, a mathematical term for an orbit of escape, an arc that suggests a mere passerby, a celestial wanderer arriving from the interstellar deep and departing just as swiftly. According to current models of celestial mechanics, such objects are rare, but not impossible. Gravitational slingshots around unseen perturbers, or the chaotic ejections from nascent planetary systems, can impart such velocity. A hyperbolic orbit is the signature of an object unbound, a visitor merely sampling the gravitational well of our star before continuing its eternal journey. But if it is merely a passive rock, tumbling through the galaxy for millions of years, why does its specific trajectory feel so profoundly intentional? The eccentricity, a value definitively greater than 1, confirms the open road of its journey. Yet, the data reveals a more nuanced story. Its path is not a simple flyby, it is a path of inversion. 3I Atlas moves against the flow, a retrograde swimmer in the river of prograde orbiting planets and asteroids. This counter-directional approach is not an efficient path for a random interloper. It dramatically increases the relative velocity of its encounter with the planets, a choice that seems to maximize interaction, not minimize it. Could a random gravitational kick from some distant star have orchestrated such a precise and oppositional entry vector? The mainstream explanation would point to statistical probability. Given enough interstellar objects, one will eventually arrive on a retrograde, hyperbolic path. The laws of physics, as we understand them, do not forbid it. Yet, the optimization of this path is what gives one pause. Consider the principle of signal-to-noise ratio, a cornerstone of experimental physics and communications technology. To detect a faint whisper against a roar of background static, one must maximize the gradient of the signal. A probe designed to passively listen to a star system, to gauge its magnetic fields, its planetary compositions, its potential for electromagnetic chatter, would benefit immensely from a high-velocity, retrograde flyby. Each planet it passes becomes a distinct data point. Its influence on the probe's own field, creating a sharp, clear signal as their relative velocities compound. The trajectory of 3I Atlas is not just a path through space, it is a meticulously planned survey line, a scan that slices across the solar system's gravitational and magnetic nodes with an efficiency that seems engineered. Is its flight path a form of cosmic cartography, designed to map our system with a single, elegant, and ruthless pass? This concept of a systemic scan leads to a deeper layer of analysis. The object's chosen route is not a straight line through empty space. Its hyperbolic arc is curved in such a way that it is compelled to pass through a series of key gravitational and magnetic waypoints. It is as if its trajectory was plotted to ensure it sampled the environments of multiple worlds, not just one. The magnetic fields of Jupiter, the solar wind interactions at Earth's orbit, the peculiar quiet of the Martian sphere, each becomes a data point on its itinerary. A natural object, subject only to gravity, would have a wider range of potential paths. The specific constrained arc of 3I Atlas seems selected from a multitude of possibilities, a route that guarantees a comprehensive layered analysis of the solar system's inhabitants. What could it be learning from the magnetic and gravitational signatures of our worlds that requires such a precise and invasive flight plan? And then, there is the matter of its departure. A reconnaissance mission by its very nature implies a subsequent action, the return of information, or perhaps the execution of a command. The hyperbolic orbit is the ultimate escape plan. Once its primary objective, whatever that may be, is complete, the object's inherent velocity and trajectory ensure a swift and unassailable exit from the sun's gravitational well. It does not linger. It does not risk capture or a second, more observable pass. It performs its function and then retreats along the open highway of its orbit, back into the galactic dark. This is not the meandering path of a natural body, it is the decisive stroke of a calculated operation. Does its unwavering commitment to escape suggest a purpose that must be fulfilled before a rapid and untraceable withdrawal? The implications of such navigational logic are profound, casting a long shadow over both exploration and defense. For future human missions to the outer planets, a retrograde hyperbolic trajectory could offer a revolutionary model. It would allow a single probe to sample multiple planetary environments at high speed, drastically reducing the time required for system-wide surveys. The energy cost would be immense, but the payoff in data could be unparalleled. We are forced to consider, then, if we are merely observing a technique that our own descendants might one day employ. Conversely, this same principle presents a terrifying paradigm for planetary defense. Our current models for predicting asteroid impacts are built upon a foundation of prograde, co-orbital motion. We watch the skies for rocks that move with us, not against us. An object on a crafted, retrograde hyperbolic path would be a ghost. Its high relative velocity would grant us minimal warning time, and its unconventional angle of approach could place it outside our standard observational sweeps. It would be a spear thrown from an unexpected direction, its trajectory optimized not for data collection, but for penetration. The very efficiency that makes it an ideal reconnaissance tool also makes it a perfect weapon delivery system. So, we must ask, as we chart its unswerving course, are we witnessing a blueprint for the future of our own exploration, or are we reading the tactical manual for our own potential obsolescence? This precise and unyielding path, however, is only one facet of its unsettling nature, for a trajectory is defined not just by its shape, but by the velocity with which it is traced. And the speed of 3i Atlas is the next piece of the puzzle, a parameter that transforms its mysterious journey into a potentially aggressive act. If its course is the drawn blade, then its velocity is the thrust. From the silent, star-drenched void between the stars it arrived, not with a herald of light or a burst of radio waves, but with a trajectory that spoke of a journey beyond human comprehension. By the 3rd of July, 2025, the object designated 3i Atlas was already a fixture in our celestial charts, its velocity a stark, unadorned fact in the data streams of observatories around the globe. 60 kilometers per second. A number that, when translated into the visceral reality of motion, transforms this visitor into a cosmic projectile, a bullet fired from the galactic dark. Its origin vector, traced backward through the interstellar medium, points unerringly toward the heart of our Milky Way, the most densely populated and dynamically complex region of our galactic neighborhood. This is not the gentle, parabolic arc of a local comet, perturbed by a passing star. This is a straight line drawn from the abyss, a path of singular, unnerving purpose. What forces, natural or otherwise, could impart such a velocity to a body of its size, and why does it seem to have been aimed directly at our stellar system? The mainstream scientific explanation seeks to anchor this phenomenal speed in the known mechanics of galactic dynamics. Astronomers suggest that 3i Atlas could be a planetesimal ejected from a young planetary system in the galactic bulge, a chaotic region where gravitational interactions between nascent stars are frequent and violent. According to current models, a close encounter with a gas giant or a stellar flyby could have flung this object out of its cradle, setting it on a billion-year journey across the galaxy. Its high velocity, then, would simply be a reflection of the immense gravitational potential well of the galactic center from which it came, a natural consequence of its tumultuous birth. The Doppler shift measurements of its approach confirm a hyperbolic excess velocity, definitively marking its interstellar provenance, while spectroscopic analysis reveals a sudden and complex activation of volatile materials as it entered the inner solar system, a behavior not entirely dissimilar to some comets from our own Oort cloud. Yet, this conventional narrative, while elegant in its simplicity, fails to account for the chilling precision of its arrival. But what if its speed is not merely a relic of its origin, but a carefully calibrated feature of its journey? Consider a more speculative hypothesis, that 3I Atlas is equipped with what we might term an astronomical clock, an internal or external mechanism synchronizing its atlas trajectory with the cyclical rhythms of our star. Its perihelion passage was not a random occurrence, but was timed to coincide with a period of heightened solar activity, a solar maximum where the sun's corona is most turbulent and the solar wind flows at its most intense. In this scenario, the object did not simply fall towards the sun. It arrived at a pre-selected moment using the increased plasma density and magnetic chaos of the active sun as a form of cover, a shroud of natural interference. Could an object be designed to exploit the very weather of a star to mask its approach? This line of inquiry compels us to analyze its trajectory not as a passive fall, but as a dynamic event with strategic implications. The first level of analysis is one of timing. The object's trajectory placed it in the inner system during a phase of peak solar wind output. For a passive natural body, this is an irrelevant detail, a mere environmental condition. But for an active probe, or an object with a specific mission profile, this opportunity provides a significant tactical advantage. The cacophony of charged particles and fluctuating magnetic fields would serve to scramble delicate sensors, create noise in communication bands, and generally degrade the resolution of our most powerful observational tools, from radar to deep space monitoring networks. Was the timing of its arrival a deliberate choice to exploit a window of reduced observational clarity? The second level of analysis concerns the element of surprise, or more accurately, the compression of reaction time. A velocity of 60 kilometers per second is not just fast, it is decisively fast. It dramatically shortens the window between detection and close approach. Our planetary defense networks, designed to track near-Earth objects over years or decades, are ill-equipped to respond to an object that transitions from a distant curiosity to an imminent passerby in a matter of months. This high-speed approach is the hallmark of a blitz tactic, a maneuver intended to minimize the time available for any potential defensive or observational response from the resident technological species. Does its speed indicate a design principle centered on minimizing engagement time with a potentially hostile system? The third level is one of penetration. At such a velocity, 3I Atlas possesses a kinetic energy that renders it largely immune to many of the passive hazards of interplanetary space. Micrometeoroid impacts, gravitational tugs from minor bodies, even the gentle but constant pressure of solar radiation become negligible factors. It moves on a course so determined, so energetically dominant, that it cuts through the diffuse fabric of our solar system with minimal interaction, like a needle through gauze. This penetration profile ensures its path remains true, its mission parameters, whatever they may be, undisturbed by the trivial friction of local space. Is its immunity to minor perturbations a sign of engineering for resilience, or simply the inevitable physics of its speed? The implications of such a hypothesis are profound, forcing a radical reconsideration of our own place and preparedness in the cosmos. If 3I Atlas was a test, a scout, or a message, its most enduring legacy may be the technological awakening it has triggered in our species. The necessity to build a planetary LiDAR network, a rapid response, interplanetary early warning system, capable of tracking high-velocity targets in real time, is no longer the stuff of science fiction, but an urgent strategic imperative. This event provides the catalyst to upgrade our asteroid defense from a statistical cataloging exercise to a dynamic, real-time monitoring and interception capability. But are we building these systems to defend against natural impacts? Or are we, perhaps unconsciously, preparing for the next visitor that might not simply pass by. As we ponder the unsettling implications of its speed and trajectory, a new and equally perplexing characteristic of 3I Atlas demands our attention. Its path was not only fast, but profoundly alien in its geometry, raising the even more disquieting possibility of a chosen flight path. The trajectory of the first confirmed interstellar object, designated 1I Oumuamua, presented a profound puzzle, but it is the path of its successor, Comet 2I Borisov, that introduces a more complex and unsettling geometry. When an interstellar visitor crosses the plane of the ecliptic at a steep inclination and in a retrograde motion, moving against the flow of nearly every planet and asteroid in our system, we are compelled to ask if this is a mere statistical anomaly or a deliberate navigational choice. The mainstream scientific explanation posits that such an orbit is a fossil record of its chaotic ejection from a distant star system. The gravitational dynamics within a protoplanetary disk, the early swirling mass of gas and dust from which planets form, are known to fling countless planetesimals into the dark. A retrograde, high-inclination orbit is a natural, if rare, outcome of this violent genesis, a random vector imprinted by gravitational interactions long ago and far away. The object becomes a passive piece of stellar driftwood, its path dictated solely by the initial conditions of its launch and the subsequent pull of galactic tides. Yet, if its journey is purely a product of chance, why would it choose the most energetically expensive and dynamically hostile path through our system, moving against the collective gravitational grain? The speculative hypothesis challenges this notion of passivity. Imagine if the steep inclination and retrograde motion were not an accident of birth, but a calculated entry strategy. An object intending to maximize its sensory acquisition of a star system would not glide comfortably within its orbital plane, it would slice across it perpendicularly. This is the first level of our analysis, the cross-cut. By intersecting the ecliptic at a near right angle, 2I Borisov maximized its interaction with the densest regions of the zodiacal cloud, the vast disk of interplanetary dust that lies along the orbital plane of the planets. This was not a peaceful cruise. It was a deliberate plunge through the system's primary debris field. The observed brightness fluctuations of the comet, particularly as it traversed this plane, could be interpreted not merely as the passive sublimation of ices, but as an active engagement with this environment. Was the comet using the dense particulate matter as a medium for analysis, a form of natural tomography where the scattering of sunlight and the composition of the dust grains could be read like a book? This leads to the second level, the long glide. A cross-sectional cut provides a snapshot, but a sustained trajectory along and across the plane offers a continuous data stream. The object's path can be seen as unfurling a kind of dust radar along the ecliptic. As it moved, its coma, the cloud of gas and dust surrounding its nucleus, would interact differently with the varying densities of the interplanetary medium. These interactions could serve as a form of calibration, a way to map the magnetic and electric fields that are woven through the dust, fields that are shaped by the solar wind and the planets themselves. The hydrogen line, a fundamental frequency emitted by neutral hydrogen that is a cornerstone of radio astronomy, might be just one thread in a far richer tapestry of electromagnetic information that such an object could be designed to detect. Could the comet's very surface have been engineered to react to these specific environmental stimuli, its outgassing patterns not random, but a programmed response to the data it was collecting? The third, and most profound, level of analysis considers the signal. A high-inclination retrograde orbit is an extreme outlier, a signature so distinct it stands out, against the background noise of natural celestial mechanics. In a universe governed by probability, the most likely path is the one of least resistance, which this is not. This forces us to contemplate whether the inclination itself is a form of messaging. It is a beacon of artificiality, a deliberate deviation from the expected. The plane of the ecliptic is not just a physical location, it is the plane upon which our civilization, with its radio telescopes and orbiting observatories, is most concentrated. Was this angular, contrary path a way to ensure it was seen by the maximum number of potential observers located on or near that plane? Was the trajectory itself a complex cipher, a mathematical signature intended for a recipient who understands the language of orbital dynamics? The selective consequences of such a trajectory are far-reaching. By choosing this path, the object effectively transformed Earth and the other inner planets into unwitting measurement stations. Our scientific community, by observing the comet's passage through the zodiacal light and its interactions with the solar wind, inadvertently conducted a system-wide tomography of our own interplanetary environment. We gained unprecedented data on the density and composition of dust clouds that we normally observe from within. This benevolent outcome, however, is shadowed by a more pragmatic concern. The object's passage stirred the interplanetary medium, and its predicted course through the densest bands of orbital debris raises a silent alarm. Our geostationary satellites, the backbone of global communications and weather monitoring, orbit within this delicate zone. A sustained campaign of such high-inclination visitors, each churning up the dust, could pose a novel and unanticipated hazard. Are we, in our efforts to understand these visitors, merely compiling data, or are we being compelled to develop new protocols for orbital safety, guided by an unseen hand? This manipulation of local space-time geometry leads us to a final, and perhaps the most unsettling, gravitational question. If an object can choose its angle of attack with such precision, could it also master the forces that govern its speed? The principles of gravitational assist are well understood. Our own Voyager and Pioneer probes have used the planets as slingshots to achieve velocities that would otherwise be impossible. A natural body, tumbling through a system, will have its trajectory bent by these same forces, its path, a predictable arc, dictated by the immutable laws of Newton and Einstein. The path of 2I Borisov, when charted, showed the gentle curvature expected from the Sun's gravity. But what if, for a future visitor, the data reveals a subtle anomaly? What if the gravitational pull of a planet like Jupiter or Saturn imparts not just a bend, but a precise, non-Keplerian adjustment to its velocity? The mainstream view would search for non-gravitational forces, the gentle jetting of outgassing material acting as a natural thruster. This is a perfectly sufficient explanation, one that aligns with our knowledge of cometary physics. It accounts for the slight deviations without invoking intelligence. Yet, the speculative hypothesis pushes us to look deeper. What if that outgassing is not a random process but a controlled one? The concept of a non-gravitational force is a catch-all term for accelerations we cannot attribute to gravity alone. In a natural comet, these forces are chaotic, driven by the uneven heating of its surface. But what if the vents and fissures on an artificial object were engineered to release jets of vaporized material at precise moments? A carefully timed burst during a close planetary passage could use the planet's gravity well as a leverage point, turning a simple swing-by into a powered maneuver. The object would not merely be a passive stone skipped across a gravitational pond, it would be an active swimmer, using the currents to its advantage. The resulting trajectory would be indistinguishable from a natural one to a casual observer, but upon meticulous analysis, it would reveal a pattern of optimized course corrections. Could the apparent randomness of a comet's activity mask a sophisticated form of celestial navigation? This notion escalates the hypothesis to another level. An object that can perform gravitational assists with active course correction is not just passing through, it is touring. It is maximizing its exposure to the various components of the star system, perhaps using each planetary encounter to alter its inclination or its perihelion to achieve a new observational vantage point. Jupiter could be used to crank the orbit into a higher inclination, Saturn to fine-tune the timing of its arrival in the inner system. Each maneuver would be a deliberate choice, a selection from a menu of possible paths through the gravitational labyrinth. The entire solar system, in this view, becomes a dynamic toolkit for the visitor. But to what end? Is this efficient pathfinding merely for the purpose of exploration, or does it suggest a more targeted mission profile? The implications of an active gravitational strategy are profound, forcing us to reconsider the very nature of the objects we observe. A natural body is a prisoner of its initial momentum and the forces acting upon it. An artificial one is a pilot. The distinction lies in the signature of its movement. We must therefore ask, as we refine our models and our observational techniques, are we looking for the wrong thing? We search for radio signals or structured light, but the first definitive proof of extraterrestrial engineering might be written not in electromagnetic waves, but in the silent, elegant mathematics of an orbit that is just a little too perfect, a gravitational assist that is just a little too efficient. The laws of physics provide the canvas, but who or what is holding the brush? And if such a navigational intelligence exists, what must it have learned about the structure of our system and our place within it by so masterfully playing its gravitational keys? This calculated dance with fundamental forces suggests a purpose far beyond mere transit, prompting the next inevitable inquiry. Was this gravitational interplay a one-time event, or is it a standard procedure? A repeatable method that implies a prior and perhaps ancient familiarity with our local cosmic architecture. The trajectory of the interstellar object designated 3I Atlas presents a navigational puzzle of profound elegance and implication. When humanity's Voyager probes swung past the giant planets, they performed a carefully choreographed celestial dance, using the immense gravity wells of Jupiter and Saturn as slingshots to gain velocity and alter their course. This technique, gravitational assist, is a cornerstone of modern astrodynamics, a way to harness the fundamental forces of the cosmos for a predetermined purpose. The path of 3I Atlas, upon meticulous reconstruction, suggests a series of subtle but precise gravitational interactions with the smaller bodies and the diffuse outer reaches of our solar system's gravitational field. According to current models, a natural object on a hyperbolic trajectory could experience minor perturbations, its path nudged by the tiniest of tugs from distant planets or the collective pull of the Kuiper belt. Scientists suggest this could be due to a fortunate, albeit complex, alignment of gravitational influences, a natural billiards shot on an interstellar scale. The object's outgassing, its jets of water vapor and carbon dioxide, could provide the minor propulsion necessary to place it on the optimal approach vector for such an assist, a passive beneficiary of celestial mechanics. But that does not account for the statistical improbability of its final trajectory, a path that seems less like a random deflection and more like a calculated insertion into a specific corridor of space. The observed asymmetries in its coma, the lopsided ejection of material, often correlated precisely with the moments of greatest gravitational shear, as if its internal rotation was being actively managed to use outgassing as a form of attitude control. This combination, reactive jetting and gravitational pumping, creates a system of course correction of such finesse that it borders on the intentional. Could a natural object, a simple lump of ice and dust, possess such an innate, dynamic understanding of its own inertia and the forces acting upon it? The very precision with which it seems to have bounced from one microgravity well to another implies a level of control that transcends the chaotic nature of cometary behavior. Is it possible we are not witnessing a rock tumbling through space, but a vessel executing a pre-planned navigational sequence, using the solar system's own gravity as a highway? The implications of this behavior can be analyzed across a spectrum of escalating complexity, beginning with the concept of fine-tuning. At its most basic, a gravitational assist provides a few critical meters per second of delta V, a minor adjustment that can mean the difference between an optimal exit vector and a less desirable one. For a natural object, such fine-tuning is irrelevant. Its destination is the void, and its path is dictated by chance. For an object with intent, however, every meter per second is precious, a means to ensure it arrives at a specific point in the interstellar medium at a specific time. The data suggests 3i Atlas performed these micro-adjustments with an efficiency that seems almost practiced. This leads to the second level, the probe hypothesis. An object could deliberately enter a gravitational alley using the complex and shifting gradients of a planet's field to create a sensor shadow, a zone where our observational capabilities are momentarily confused or occluded. This would not be a maneuver of propulsion, but one of stealth, using fundamental physics to mask its true nature or its departure trajectory. What if the very gravitational assists we are trying to map are, in fact, a deliberate act of obfuscation? The most profound level, however, is that of super-maneuverability. Imagine an object not content with a single slingshot, but capable of chaining a series of them together in a rapid, sequential dance through the inner solar system. Using a combination of precise outgassing and gravitational kicks, it could use the gravity of one body to fling itself towards another, creating a sweeping reconnaissance path in a single, graceful pass. This is not a theory of passive drift, but of active exploration. The energy requirements and navigational forethought for such a maneuver are staggering, far beyond our own capabilities. If this is the case, then 3i Atlas was not merely passing through, it was conducting a systematic survey. The elegance of its potential flight path suggests a technology that has mastered the art of orbital dynamics to a degree we can scarcely imagine. What profound knowledge of the cosmos is required to ride the gravitational currents with such effortless grace? The consequences of this possibility are twofold, presenting both a tantalizing opportunity and a sobering warning. If we can decipher this dance, if we can learn the principles behind such efficient gravitational manipulation, we could revolutionize our own space exploration. Missions to the outer planets and beyond could be launched faster, with less fuel, and with greater precision. The entire solar system would open up to a new era of cheap, rapid transit. We would have learned a fundamental trick of interstellar travel from a master, but we must also consider the inverse scenario. If an extraterrestrial object can use these techniques for efficient entry and exploration, it could also use them for evasion. A sophisticated probe could use a complex series of gravitational assists to make its trajectory unpredictable, to avoid capture or observation, or to position itself in a strategically advantageous location within our system. The same technique that promises a golden age of exploration could also be the hallmark of a technology that wishes to remain unseen. If this is a tool, then who else might be wielding it, and for what purpose? This line of inquiry inevitably draws our attention away from the object's trajectory and towards its very substance, its chemical soul. For while its path hints at intelligence, its composition may whisper of intent. On the 6th of August, 2025, the James Webb Space Telescope turned its golden eye towards the departing visitor and made a discovery that recalibrated the entire investigation. Spectral analysis revealed a sudden, dramatic outburst, not merely of water, but of a gas in a ratio that defied all conventional cometry models, an exceptionally high proportion of carbon dioxide to water. In a typical comet, water is the dominant volatile, with carbon dioxide and carbon monoxide present as secondary components. This was different. This was an atmosphere dominated not by the stuff of life, but by a heavy, inert gas, erupting in a concentrated, localized plume. The standard explanation points to heterogeneity. The object could simply have a layered composition, and the James Webb instrument happened to catch a jet emanating from a region rich in frozen carbon dioxide. As the sun's heat penetrated its complex interior, it could have tapped a pocket of this volatile material, causing a temporary spike in its emission signature. It is a plausible, naturalistic interpretation. Yet, The timing and the specificity of the release give one pause. This was not a slow, steady sublimation, but a sharp, almost surgical ejection. The high carbon dioxide to water ratio is particularly telling. On Earth, we understand carbon dioxide as a simple component of our atmosphere, a greenhouse gas, a byproduct of combustion. But in the realm of space, chemistry takes on different meanings. A concentrated release of carbon dioxide could serve to rapidly alter the local environment around the object, perhaps as a propulsive burst far more efficient than water vapor for a specific maneuver. Or, considered more darkly, it could be a form of obscurant. A cloud of carbon dioxide is difficult to probe with certain spectroscopic tools. It could be a temporary cloak, a smokescreen deployed at a critical moment. And if carbon dioxide, why not other, more complex compounds? The detection of this gas forces us to expand our thinking beyond geology and into the realm of function. What if the chemical composition of an interstellar object is not just a relic of its formation, but a part of its active toolkit? This leads to a more unsettling speculative hypothesis. We are accustomed to thinking of weapons in terms of kinetic impact or energy discharge, but what constitutes a weapon for a truly advanced intelligence? A concentrated, targeted release of a specific gas into a planet's atmosphere could, over time, induce catastrophic climate change, a slow and undetectable act of terraforming or termination. A plume of a complex organic molecule could act as a catalyst, disrupting prebiotic chemistry on a young world, or perhaps even encouraging it in a controlled manner. The concept of a chemical weapon becomes astronomical in scale. The high carbon dioxide ratio observed by the James Webb Telescope could be a mere footnote, a trivial byproduct of its propulsion. Or it could be a single, visible sample from a vast and sophisticated arsenal of chemical agents, each with a purpose we have not yet begun to fathom. Is the distinction between a comet's natural outgassing and a deliberate chemical broadcast merely a matter of perspective and intent? And if this was a sample, what might a full-scale deployment look like? The very act of identifying this release forces us to confront the limitations of our own scientific language. We label it carbon dioxide because that is the molecule our instruments detect. We understand its role in our own planetary systems, but we lack the context to understand its role for another intelligence. It could be a waste product, a coolant, a propellant, a signal, or indeed a reagent in a process whose end goal we cannot discern. The James Webb data provides a fact, a hard point of evidence in the vacuum of space. Yet, this fact is a key that does not clearly fit any lock. It unlocks both the door to a deeper understanding of cosmic chemistry and the door to a much darker, more uncertain universe, where the very air can be a weapon. The calm academic analysis of spectral lines thus leads us to a precipice, forcing us to ask not just what something is, but what it is for. As we continue to sift through the data from that August observation, we are left to wonder, were we witnessing a simple geological event, or were we, for the first time, reading a single sentence from a manual of cosmic warfare? The initial data appeared as a mere curiosity, a subtle shift in the infrared spectrum captured by the James Webb Space Telescope in early August 2025. It was a transient outgassing event, a brief, violent exhalation from the object known as 3I Atlas. Standard cometry science would classify this as a typical eruption, where subsurface ices, warmed by the sun, flash into vapor, carrying with them a cocktail of dust and other volatile compounds. The spectra confirmed the presence of water vapor, a commonplace finding, but it was the overwhelming, almost aggressive abundance of carbon dioxide that gave analysts pause. The ratio was inverted, skewed heavily towards the carbon-based gas, a composition more akin to a distant Kuiper belt object, suddenly thrust into the inner solar system than a typical comet. Could a simple change in solar proximity alone account for such a profound and sudden chemical imbalance? This anomalous outgassing event forces us to reconsider the very nature of a comet's coma. According to current models, the coma is a temporary, tenuous atmosphere, a cloud of neutral gas and dust lifted from the nucleus by solar heating. Its chemical makeup is a historical record, a fingerprint of the comet's formation in the early solar system. The sudden surge of carbon dioxide could be explained by the exposure of a fresh, pristine pocket of volatile material, buried deep within the nucleus, and now uncovered by a landslide or a structural collapse. The observed variability with solar radiation would support this, suggesting new vents opening to the sun's relentless light. Yet, this conventional explanation feels insufficient, for it treats the coma as a passive, dissipating cloud, a mere bystander in the vacuum of space. What if the coma is not an effect, but an instrument? A more speculative hypothesis begins to take shape, one that views this sudden release not as a geological accident, but as a deliberate act of environmental modulation. The high concentration of carbon dioxide, when mixed with water vapor and other trace gases, could be engineered to alter the fundamental electrical properties of the coma plasma. The coma is not a true vacuum. It is a partially ionized gas, a soup of neutral molecules, free electrons, and positive ions. By introducing a specific, dense cocktail of polar molecules like water and carbon dioxide, an agent could dramatically increase the plasma's dielectric constant. This is not merely a cloud of gas. It becomes, in essence, a temporary, vast, and dynamically reconfigurable antenna. Is the object not just shedding its ices, but actively tuning the very medium that surrounds it? The evidence for this environmental engineering is etched into the light we receive. The infrared spectra are not just a list of ingredients. They are a record of a violent, focused burst, a geyser of volatiles released with a precision and timing that seems to defy random geological processes. The variations in outgassing correlate with solar flux not as a simple, predictable response, but with the complex rhythm of valves being opened and closed. Even the object's optical color, shifting as it approaches the sun, hints at a change not just in dust composition, but in the refractive and absorptive properties of the gaseous shroud itself. Could these chromatic shifts be a secondary effect of a far more profound transformation occurring within the comet's manufactured atmosphere? This leads us to the first level of analysis: environmental modulation. The primary function of this gas release may be to alter the electrical conductivity and permittivity of the coma. A denser, more chemically complex plasma would behave differently under the influence of solar wind and interplanetary magnetic fields. It would be less susceptible to simple dispersal and more capable of maintaining a coherent structure. This is not a cloud dissipating. It is a medium being prepared. The carbon dioxide and water are not waste products. They are the components of a circuit. Are we observing the construction of a platform, a stage being set for a performance we have yet to comprehend? The second level considers the morphology of the resulting tails. A naturally occurring comet may exhibit a dust tail and an ion tail, shaped passively by solar radiation pressure and the solar wind. The tails of 3I Atlas, however, display a peculiar coherence. They do not fan out diffusely. They maintain defined boundaries, at times appearing almost tubular. A plasma with a carefully engineered dielectric constant could, in theory, guide electromagnetic energy in a specific manner. It could form a natural waveguide, a funnel for energy that channels it along a predetermined path, rather than allowing it to scatter into the void. The beautiful, ethereal tails we see through our telescopes may not be mere streamers of dust and gas, but optimized conduits for the transmission of power or information. Is the object not just moving through space, but actively laying down its own cables as it travels? The third, and most profound level, is that of activation and interaction. A prepared medium and a shaped conduit suggest a purpose: interaction with the environment. A dense, electrically active plasma cloud swept through by the solar wind, would be a prolific source of charged particles. This could be a form of soft weaponry, a way to locally disrupt the delicate equilibrium of near space. A spacecraft passing through such a cloud could find its external sensors blinded by static, its radio communications phased, shifted, and rendered unintelligible. It would be an area denial system, not through kinetic impact, but through electromagnetic suffocation. The very signals we use to navigate the void and speak across planets could be selectively nullified within these chemical clouds. Does this object carry not a warhead, but a scalpel, capable of performing precise surgery on our technological capabilities? The implications of this are both a tantalizing opportunity and a grave warning. For future missions, venturing into the deep solar system and beyond, understanding how to communicate through such turbulent plasma environments is paramount. An object that can generate and control these clouds could provide an unparalleled natural laboratory, a chance to test new models of X-plasma communication. The risk, however, is that the interplanetary communication window, the clear channel upon which all our spacecraft rely, could be locally and deliberately narrowed or closed when one of these chemical clouds passes through. Our network of probes and landers, from Mars to the outer planets, could be temporarily isolated, their voices silenced by a seemingly natural, yet intelligently directed, atmospheric event. Have we been considering space as a passive medium for our exploration, when in reality, it can be made active and hostile by a will we do not yet understand? This entire construct, from the initial gas release to the potential for electromagnetic disruption, hinges on the idea of a trigger, a signal to move from a passive state to an active one. The chemical changes we have documented are profound, but they are merely the preparation of the canvas. The act of painting, the moment of activation, must still be to come. What force, what final ingredient, is required to transition this vast, tuned antenna from a state of potential to one of manifest power? The answer may lie not in the invisible chemistry of the gas cloud, but in a visible, dramatic transformation witnessed by observers across the globe in the summer of 2025, a shift in hue from a dull yellow to an impossible, ethereal blue as it swung near the sun. The language of the universe is written in light, and light, when passed through a prism, reveals its vocabulary as color. It is the first and most fundamental property of matter we can perceive, a silent declaration of composition, temperature, and state. When an object traversing the void undergoes a chromatic shift, it is not merely a change in hue, it is a change in dialect, a potential rewriting of its very identity. The object designated 3I Atlas presented us with such a lexicon shift, a slow, deliberate metamorphosis from a dull, solar-reflective gold to an anomalous, self-luminous blue as it curved around our Sunday. This was not the simple fading of a dusty rock, but an active, spectral transformation. Could such a shift be more than a physical process? Could it be a status indicator, a beacon signaling a change in operational mode? According to current models of cometry science, a change in color is typically attributed to the thermal processing of its surface. As a comet approaches the sun, volatile ices sublimate, lifting pristine dust from the nucleus and exposing different layers of material to solar radiation. The initial golden hue could be explained by a crust rich in complex organic molecules, known as tholins, which tend to reflect yellowish-red light. As this mantle was stripped away by increasing heat, the underlying ices, primarily water, could have been exposed, potentially scattering light in a way that appears bluer. Scientists from the Atlas Robo Network, observing the object from March 28 to August 29, 2025, documented this shift with meticulous precision, correlating it with a sharp increase in brightness and the expansion of its coma. The data showed spectral features consistent with the emergence of diatomic carbon and cyanogen emission bands, molecules known to produce a greenish-blue glow in the COME of certain active comets when illuminated by sunlight. This is the established narrative, a story told by the excitation of simple molecules under a stellar furnace. But that narrative rests on the assumption that the surface of 3I Atlas is a passive, inert landscape, merely reacting to external stimuli. What if its surface was an active participant? The timing and crispness of the color transition challenge a purely geological explanation. The shift was not a gradual blurring of spectra, but a defined change, as if a threshold was crossed. This invites a more speculative hypothesis, that 3I Atlas was coated in a form of smart paint, an engineered layer of nanoscale particles designed to alter their reflective properties in response to specific environmental triggers, such as a precise temperature threshold or a particular flux of solar radiation. In this scenario, the color change was not a byproduct of activity, but the very signal of its initiation. The outgassing and coma expansion would then be a consequence of this activation, not its cause. If the color was a deliberate signal, what was the intended message, and who was the intended recipient? This leads us to the first and most conservative level of interpretation, the internal signal. Here the color shift is a built-in diagnostic, a simple, biological-like indicator of a new phase in the object's cycle. Much like the color change in a thermochromatic strip, the shift from gold to blue could signify the commencement of vigorous outgassing, a switch from a dormant, cruise state to an active, maneuvering state. The object's internal systems, having reached a predetermined perihelion parameter, trigger a release of stored volatiles, and the changing surface color is a mere side effect, a cosmic on light illuminated for anyone who cares to look. It is an efficient, if rudimentary, form of internal bookkeeping. But is such a simplistic interpretation sufficient for an object that has defied every other convention? We must, therefore, consider the second level, the external signal. If the color change is intentional, it transforms from a status light into a beacon. The specific wavelength of blue it emitted, a color not commonly dominant in natural celestial bodies, could be a deliberate choice for visibility against the backdrop of space. It is a signal designed to be noticed, a flash of cobalt in a sea of stellar white and dusty red. This was not a shout, but a calibrated pulse, a synchronizing flash aimed at an unknown observer. The change coincided with its closest approach to the Sun, the most prominent gravitational and energetic landmark in our system. Was this a check-in point, a way for the object to announce its successful navigation of a key waypoint to a listening network? Or was the signal meant for us, a way to ensure we were paying attention at the most critical moment of its journey? Pushing the speculation to its tactical extreme, we arrive at the third level of analysis, the color as a strategic code. In this framework, the chromatic sequence is not a single signal, but a multi-phase status code. The initial gold represents a passive, reconnaissance mode, observing, collecting data, and remaining as inconspicuous as a foreign object can be. The transition to blue, then, marks the end of the observation phase and the beginning of a more active engagement, the commencement of its primary mission. This need not imply hostility. It could signify the deployment of scientific instruments, the initiation of a communication attempt, or the jettisoning of a smaller probe. The precise spectral signature becomes a language we cannot yet decipher, a set of instructions being executed or a readiness state being communicated to other elements of a potential system. If gold is standby and blue is execute, what command was being carried out in the silent vacuum between the orbits of Mars and Earth? The implications of this are profound, forcing a paradigm shift in how we monitor near-Earth space. If we can learn to read this language of color and light, we move from passive observation to active interpretation. We could design an early warning system not based solely on an object's trajectory, but on its real-time spectral emissions. A sudden shift towards a specific hue could indicate an imminent outburst, a course correction burn from a hidden propulsion system, or a change in operational intent. This would herald the dawn of a new discipline, spectral meteorology for planetary security, where we forecast not weather, but behavior. We would no longer just track rocks, we would attempt to diagnose visitors. But to truly diagnose an object, one must first understand the nature of its heart, the engine that drives its activity, and the evidence suggests the heart of 3I Atlas was unlike any cometary nucleus we have ever known. The Hubble Space Telescope, on the 21st of July, 2025, provided the most precise measurement of the nucleus, constraining its diameter to between 0.32 and 5.6 kilometers. This size, however, was only part of the puzzle. The true anomaly lay in the scale of its activity. Conventional comets, like the well-studied 67P Churyumov-Gerasimenko, exhibit localized jets, geysers of gas and dust, erupting from a few discrete sunlit areas on an otherwise dormant nucleus. The activity of 3I Atlas was different. Analysis of its coma, structure and dust production rates indicated that a significantly larger percentage of its surface was actively outgassing. The entire sun-facing hemisphere seemed to be participating in a coordinated release of material, a global eruption rather than a localized one. This was not a handful of volcanic vents, it was the entire surface breathing. What unknown power source could drive such widespread and sustained activity from a body of such modest dimensions? The coma of a comet is its breath, the visible exhalation of its frozen heart as the sun's warmth stirs it from its slumber. For a typical comet, this is a hazy, diffuse shroud, a temporary atmosphere of gas and dust. Yet, when the Hubble Space Telescope turned its gaze toward 3I Atlas in late July 2025, it did not see a typical coma. It witnessed a storm. The coma was anomalously dense, optically thick, a churning cloud that obscured the nucleus within far more effectively than any known comet of a comparable size. The nucleus itself, estimated to be between 0.32 and 5.6 kilometers in diameter, was unremarkable in its dimensions, but the activity emanating from it was not. The sheer volume of outgassing material implied a surface not merely pockmarked with a few volatile vents, but one that was fundamentally, profoundly active. The effective active area, the percentage of the surface contributing to this outburst, was calculated to be orders of magnitude greater than that of any short or long-period comet in our records. A comet of this size should not possess such a global, simultaneous capacity for eruption. According to current models, such intense activity is the hallmark of a young, pristine comet on its first plunge into the inner solar system, its surface layers still rich with volatile ices. Yet, 3I Atlas's trajectory and spectral signatures tell a more complex story, one of age and prior journeys. Scientists suggest this could be due to a unique subsurface structure, perhaps a labyrinth of interconnected pores and caverns that channel solar energy deep into the nucleus, triggering widespread sublimation from within. But that elegant explanation stumbles before the sheer coordination of the event. This was not a chaotic global thaw. It was a synchronized awakening. What if the very concept of an active area requires redefinition, not as a passive geological feature, but as a dynamic, controllable system? The conventional view of cometary jets is one of brute thermodynamics. A patch of frozen carbon monoxide or water ice heats up, sublimates, and ruptures the overlying dust, creating a single, chaotic geyser. The resulting force is a slight, asymmetrical nudge, a perturbation on the comet's orbit that astronomers meticulously account for in their ephemeris calculations. At a microscopic level, this is a simple story of pressure and release. A new vent opens, internal vapor pressure surges, and a localized acceleration vector is imparted to the nucleus. This is the standard picture of non-gravitational forces, a key component in understanding the orbital evolution of comets. However, The Hubble data from 3I Atlas reveals a coma with a complex filamentary structure, suggesting not a few large jets, but a multitude of smaller, precisely located sources. The outgassing pattern does not resemble the stochastic spray of a melting ice ball. It appears organized. The speculative hypothesis then emerges. What if 3I Atlas is equipped not with simple vents, but with a network of synchronized nozzles, a matrix of microthrusters that can be thermally commanded to open and close? This would transform the surface from a passive landscape of geological chance into an active, engineered skin capable of managing its own outgassing. Each tiny jet would contribute a minuscule force, but in concert, they could generate a controlled and sophisticated thrust. Could the very dust we see as a sign of primitive chaos instead be the exhaust of a deliberate and finely tuned propulsion mechanism? This leads us to the mesoscale perspective, the level of coordination. If these proposed micronozzles operate not in isolation, but as a coordinated matrix, their purpose transcends mere outgassing. They become a system for navigation. By selectively activating specific clusters of nozzles across its surface, the object could manage not just the magnitude of its non-gravitational acceleration, but its direction. It could, in theory, fine-tune its trajectory. This would explain the observed efficiency of its active area. It is not that a larger percentage of the surface is naturally volatile, but that a larger percentage is being utilized. The matrix could optimize the direction of the tail, perhaps even shaping the coma's interaction with the solar wind for purposes beyond our current comprehension. The observed, unusual density of the coma could then be a shield, a smoke screen generated on demand, or a byproduct of intense, focused activity. While mainstream planetary science would attribute such complex coma structures to the interplay of solar radiation pressure and the nucleus's rotation, the level of sustained structure in 3I Atlas's coma presents an anomaly. The jets appear to be modulating, not just with the comet's spin, but against it. So we are left to ponder, is the intricate dance of dust and gas we witness the simple result of solar heating on a strange topography, or is it the visible signature of a hidden control system, a method of celestial guidance that we have only just begun to imagine? On a macroscopic scale, the implications of such a synchronized nozzle array become profound. Consider the interaction with the solar wind, that relentless stream of charged particles flowing from the sunday. A normal comet's ion tail is formed when solar wind particles interact with ions in the coma, a process dictated entirely by magnetic fields and plasma physics. But if the outgassing from 3I Atlas could be pulsed, if these hypothetical phase cannons could fire in coordinated bursts, they would not merely release gas. They would create structured pressure waves that could actively perturb the local plasma environment. This would be an active dialogue with the sun's fury, not a passive reaction. The object could, in theory, use its own outgassing to create a protective bubble or a focused channel within the solar wind, altering the very space around it. This ventures far from conventional cometary science and into the realm of advanced plasma propulsion concepts, like magnetoplasmodynamic thrusters, which use magnetic fields to control ionized gas for thrust. While 3I Atlas shows no detectable magnetic field, the sheer density and velocity of its outgassing could achieve similar, if transient, effects through pure fluid dynamics. The question then shifts from what is it to what is it doing? Is the vast, active surface of 3I Atlas merely a natural wonder, or is it the engine room of a vessel employing a technology that blurs the line between a celestial body and a spacecraft? This line of inquiry carries profound and unsettling consequences for our own future in space. There is a selective pressure at work here, a lesson hidden in the dynamics of this object. If a future human probe could learn this active surface technique, it would revolutionize interplanetary travel. A spacecraft could navigate using locally sourced volatiles, water ice from asteroids, carbon dioxide from Martian poles, not as mere reaction mass in a bulky engine, but through a distributed network of surface thrusters. It would be a form of biomimicry, emulating the very process we now observe. The spacecraft's skin would become its engine, allowing for incredibly delicate maneuvers and course corrections with minimal onboard propellant. This is the hopeful consequence, the spark of human ingenuity, inspired by the unknown. But the same principle casts a long shadow. The very technique that could empower our exploration could also be used by others, or perhaps is already being used. The ability to generate a dense, controllable coma is not just a propulsion method, it is the perfect camouflage. By regulating its outgassing, an object could disguise its true size, shape, and even its mass. It could present the appearance of a harmless, if unusually active, comet, while masking a different nature entirely. The anomalous active area, therefore, is not merely a scientific curiosity, it is a strategic capability. Do we see in 3I Atlas a natural prototype for a future human technology, or are we witnessing the operational signature of a technology that has long since mastered its environment? As we stand before this enigma, our instruments probing its dusty veil, we are forced to confront the limitations of our categories. We call it a comet because it fits no other classification in our catalogues, but its behavior whispers of a different ontology. The synchronized activity of its surface challenges the very definition of a passive celestial body. It suggests a level of internal organization, a capacity for coordinated response to external stimuli that we do not associate with lumps of ice and rock. This is not the predictable clockwork of orbital mechanics, but the subtle, dynamic signature of a complex system. The vast active area is more than a source of brightness. It is a portal into the object's fundamental nature. Is the brilliance of 3I Atlas merely the reflection of sunlight on ejected dust, or is it the glow of a deeper, more formidable power, one that commands its own interaction with the fabric of space itself? And if we were to look past the blinding glare of its coma, past the synchronized jets and the manipulated plasma, what fundamental structure of dust and rock would we find that allows for such a breathtaking and perhaps deliberate performance? This very question pulls our gaze forward to a different kind of observation, one that measures not light but its hidden polarity. On the 5th of September, 2025, a team of astronomers trained their polarimeters on 3I Atlas, seeking to understand the precise nature of its dust grains by analyzing the way they scatter sunlight. What they recorded was not just unusual, it was unprecedented in the annals of cometary science, a deep negative polarization branch. This specific signature in the light tells a story of particle size, composition, and structure, far stranger than the simple silicates and carbon compounds found in every other comet we have studied. This anomalous polarization is a direct clue to the fundamental architecture of the object, a ghostly imprint of its solid form that persists even after its volatile gases have dissipated into the void. How does the intricate, engineered activity of its surface relate to the profound and alien composition of its core? The answer may lie in the correlation between its eruptive behavior and the hidden structure of the dust and rock from which it is truly built. Dust, in the annals of cometary science, has always been seen as a passive byproduct, the detritus of sublimation and disintegration. A comet's tail, that ethereal brushstroke across the celestial canvas, is merely the consequence of solar radiation pushing minute particles away from the nucleus. It is a beautiful, predictable, and ultimately chaotic phenomenon. Yet, with the object designated 3I Atlas, we are compelled to re-evaluate this foundational premise. The dust surrounding this interstellar wanderer does not behave as a simple consequence. Its structure and composition suggest a degree of organization that challenges our very definitions of a natural object. Could it be that this dust is not a residue, but a deliberately deployed component, a sophisticated material with a purpose that extends beyond mere physics. Is the coma of Three-Eye Atlas not a cloud of debris, but a constructed shield, a dynamic and intelligent interface with its environment? From a mainstream scientific perspective, the anomalous polarization data presents a formidable puzzle. Polarimetry, the study of how light waves oscillate after interacting with a material, is a powerful diagnostic tool for understanding the physical properties of cometary dust. When the James Webb Space Telescope and a global network of terrestrial observatories turned their instruments towards Three-Eye Atlas on the 5th of September 2025, they recorded a signature that defied immediate classification. The data revealed a profound negative polarization branch, a characteristic deeply atypical when compared to the polarization profiles of every known comet in our solar system, from the dusty rich Hale-Bopp to the fragile nucleus of Ison. According to current models, such a signature points towards a population of dust grains that are exceptionally uniform in size, possess a complex, non-spherical geometry, or are arranged in highly porous, aggregate structures. Scientists suggest this could be due to a unique mineralogical composition forged in an alien protoplanetary disk, one rich in specific silicates or exotic carbon chains that crystallized under conditions unimaginable around our own Sunday. The conventional explanation is that we are witnessing the natural outcome of its extrasolar origin, a simple reflection of a different formation history. But does a mere difference in origin adequately account for the sheer coherence and stability of this polarimetric anomaly, which persists across millions of kilometers and fluctuates with a rhythm that seems almost too deliberate? This is where the boundary of known science blurs, and a more speculative hypothesis must be considered. What if the particles ejected by Three-Eye Atlas are not merely uniform, but are engineered? The concept of phase-tuned polarity suggests that each dust grain could be shaped and composed to scatter light in a specific, coordinated manner. Individually, they are simple specks. Collectively, they could function as a vast, diffuse optical instrument. The profound negative polarization branch may be the telltale signature of these particles acting in concert, their combined effect creating a form of spatial coherence. This is not a simple cloud of dust. It is a metamaterial, a gossamer-thin lens of astronomical proportions. Could this intricate dust field be a form of adaptive camouflage, a shroud designed not to hide, but to distort and manipulate the very light we use to observe it? To comprehend the full implication of this idea, we must analyze it across three distinct scales. At the microscopic level, the individual particle geometry is paramount. A perfect sphere scatters light in one way, a complex fractal-like aggregate, or a needle-shaped particle, scatters it in another. The anomalous polarization data strongly implies that the dust of Three-Eye Atlas is dominated by such complex shapes, perhaps even microscopic helices or chiral structures that preferentially filter and twist incoming starlight. This is not a random assortment of jagged fragments, but a population with a startling degree of morphological consistency. What natural process could produce such a homogeneous yet intricate array of microscopic architectures across trillions upon trillions of individual particles? At the mesoscopic level, we transition from the individual to the collective. Here, the entire dust cloud, the coma, begins to take on a new role. It is no longer a passive screen but an active medium. The specific arrangement and density gradient of these specially shaped particles could be structuring the propagation of electromagnetic waves through the cloud. This organized dust field could be acting as a phased array, not for radio waves, but for visible and infrared light. It could be diffracting, focusing, or defocusing the light from the nucleus behind it, creating a dynamic and shimmering mirage in the void. The coma becomes a lens without a solid body, a fluctuating optic that can potentially adjust its properties in real time. If this is the case, then what we are imaging is not the true object, but a carefully projected image, a luminous decoy shaped by a billion-kilometre-wide apparatus of dust. This leads to the macroscopic, the truly staggering scale of the phenomenon. The dust shroud of 3I Atlas spans millions of kilometres. If it functions as a coherent optical element at this scale, it constitutes the largest lens ever observed in nature or by any intelligence. This optical curtain could effectively blind our most sophisticated remote sensors. Our telescopes, from Hubble to the VLT, would not be seeing the true nucleus. They would be seeing a distorted, processed image crafted by the intervening dust. Every spectral analysis, every albedo measurement, every attempt to determine its true rotation or surface features would be filtered through this immense diffuse instrument. The object controls the light. It reflects with an artistry that makes our best telescopes seem like crude pinhole cameras. Are our most advanced observatories, in their relentless gaze, merely admiring the craftsmanship of a veil, while the weaver remains entirely hidden? The consequences of this are twofold, presenting both a profound opportunity and a sobering risk. For science, this is an unprecedented chance. The opportunity lies in the development of real-time polarimetric observation algorithms specifically designed to decode such complex scattering media. By studying 3I Atlas, we could pioneer new techniques in remote sensing, learning to see through sophisticated optical interference. We would be forced to advance our understanding of light-matter interaction on a cosmic scale, yet the risk is equally monumental. If a naturally occurring interstellar object can possess such an effective dust cloak, what does that imply for the future of planetary defense? Our early warning systems for fast-moving near-Earth objects rely on clear and predictable optical and radar signatures. A dust cloak of this nature could render an incoming object virtually invisible until it was far too late for any mitigation. The very strategies we are developing to protect our world could be rendered obsolete by a cloud of seemingly innocuous dust. Is 3I Atlas demonstrating a fundamental vulnerability in our planetary security, a flaw we never before contemplated? As this enigmatic traveller continues its journey inward, it now sets its course for a series of close planetary encounters, its trajectory seemingly calibrated for a grand tour of the inner solar system. The date of the 3rd of October, 2025, is marked in observatory logs across the globe, for on that day, 3I Atlas is projected to pass within approximately 30 million kilometers of the planet Mars. From a conventional standpoint, this is a mere celestial flyby, a gravitational perturbation to be calculated and logged. The mainstream explanation is one of orbital mechanics and chance alignments, a predictable path dictated by the initial velocity and the Sun's overwhelming gravity. Yet, given the object's increasingly anomalous characteristics, one must wonder if this passage is as random as it appears. Is it merely a passive traveller, or is it, in fact, beginning a systematic and deliberate test of the various planetary environments within our star system? The object designated 3I Atlas continues its trajectory deeper into the heart of our solar system, a silent voyager on a path that seems anything but random. Its impending close passages by Mars, Venus, and Jupiter present a profound puzzle. From a conventional standpoint, a gravitational slingshot is a well-understood celestial mechanic, a way for human-made probes to conserve precious fuel by stealing a minute amount of momentum from a planet. One could posit that this is all that is occurring, a natural body following the immutable laws of gravity, its path merely a product of its velocity and the Sun's pull. Yet, the specific sequence of these planetary encounters, this deliberate threading of the needle through the solar system's most significant gravitational keyholes, invites a more unsettling interpretation. What if these passes are not a consequence of its journey, but the very purpose of it? The upcoming passage near Mars, projected for the 3rd of October, 2025, at a distance of approximately 30 million kilometers, will be scrutinized by a pre-configured network of interplanetary observers. Orbiters like MAVEN and the Mars Reconnaissance Orbiter, along with telescopes across the Earth and in space, are poised to capture every nuance of the interaction. The scientific expectation is to observe subtle perturbations in the Martian magnetotail, that elongated tear in the solar wind created by the planet's weak magnetic field. We would anticipate minute fluctuations in the density and velocity of charged particles, a ripple in the plasma, a slight increase in dust density along the Mars-Sun corridor. Such data would be a treasure trove for heliophysicists, refining our models of planetary bow shocks and magnetic reconnection. But is the value of this data merely a fortunate byproduct for us, or is it the primary objective for the object itself? This leads to the first level of a more speculative analysis, the concept of magnetic geodesy. Imagine not a comet, but a probe of immense sophistication. It does not need to land or even enter an atmosphere to conduct a survey. By passing through a planet's magnetic sphere of influence, it can effectively ring the planetary magnetic field like a bell. The resulting vibrations, the specific oscillations in the solar wind, the behavior of trapped ions and electrons are a unique diagnostic. Each planet's magnetosphere, from the non-existent field of Venus to the colossal, storm-racked dominion of Jupiter, has a distinct signature, a resonant frequency defined by its strength, structure, and composition. A careful measurement of this response would yield a perfect topological map of the magnetic environment. Could this be a form of non-contact scanning, a way to assay the structural integrity and hidden vulnerabilities of a planetary system without ever announcing its presence directly? The second level considers the principle of leverage. A gravitational assist is a passive maneuver for a dumb rock, but an active correction for an intelligent navigator. The minute adjustments required to perfectly position oneself for a planetary encounter imply a capacity for precise propulsion. The object may be using the gravity of Mars not as a primary boost, but as a fine-tuning mechanism, a gentle nudge to perfect its aim for its next target, Venus, and ultimately, the gravitational titan, Jupiter. This is not a billiard ball bouncing randomly. It is a calculated course correction on an interstellar scale. The trajectory suggests a pre-planned itinerary, a grand tour designed to test its capabilities against a variety of gravitational and magnetic regimes. What kind of navigational computer would be required to plot such a course across light years, and what is the final destination that requires such precise celestial alignment? We then arrive at the third and most disquieting level of analysis, the rehearsal. Consider the sequence: Mars, a world with a fragmented, residual magnetic field; Venus, a planet with an induced magnetosphere created by the solar wind's interaction with its thick ionosphere; and finally, Jupiter, a king with a magnetosphere so vast it could encompass the Sunday. This is not a random selection, it is a comprehensive test suite. By scanning these three radically different magnetic environments in a single, continuous journey, the object could be compiling a comparative dataset of unparalleled completeness. It is learning how different classes of planets react to an external stimulus, how their plasma shields behave under stress. The practical application of such knowledge is as profound as it is dual use. For humanity, it would unlock the secrets of space weather and enable safer navigation. But for an unknown intelligence, it would provide the key to a soft kill strategy, a way to disable orbital infrastructure, not with kinetic impactors, but with precisely calibrated magnetic interference that could scramble satellites and power grids without a single visible shot being fired. Is the solar system being used as a live-fire training ground for a technology that operates on the fundamental forces of physics itself? The implications of this selective reconnaissance ripple outward, far beyond the immediate scientific curiosity. The opportunity to construct a definitive map of plasma magnetic response for the inner planets would be a revolutionary leap for human spacefaring, a chart for navigating the invisible storms of space. Yet, the same map, in another's hands, outlines the points of greatest vulnerability. The very act of observation, it seems, can be a form of preparation. If one can predict how a planet's magnetic field will react to a specific stimulus, then one can also learn how to manipulate it. The close passage by Mars is not an endpoint, but a single data point in a much larger experiment. What other variables might be measured, and what other forces might be tested, as this silent auditor continues its journey toward the heart of our celestial neighborhood? As the object approaches its next milestone, our telescopes turn their gaze, capturing not just its position, but its evolving nature. On the 4th of September 2025, observations from the Gemini South Telescope reveal a significant development. The coma and tail have intensified, growing more complex and structured. This is the expected behavior of a comet warming as it nears the Sun, its ices sublimating under increasing solar radiation. The outgassing creates a visible atmosphere, and the iconic tail, pushed by the solar wind. It is a perfectly natural phenomenon, a confirmation of the object's icy composition. But what if the composition of that tail holds a deeper clue? What if the specific ratios of dust and plasma, the very changes in the space environment it creates in its wake, are not a symptom of its journey, but a signal of its intent? The conventional view of interplanetary space is one of near-perfect emptiness, a vacuum so profound that the very concept of weather seems absurd. Yet, the solar system is not a void. It is a dynamic ocean of plasma, bathed in the perpetual wind from the sun and dusted with the fine detritus of its formation. Within this tenuous medium, a small object, a mere kilometer across, can act as a catalyst, its passage rippling through the solar atmosphere in ways that challenge our understanding of scale and influence. We observe a comet, and we see a visitor from the distant Oort cloud. But what if its most profound function is not merely to be seen, but to actively reshape the environment through which it travels? Could a small body, seemingly at the mercy of stellar forces, itself become a force of interstellar weather? According to current models, a comet's influence on the space environment is localized and transient. As 3I Atlas approached the inner solar system, solar heating would have sublimated its volatile ices, releasing gas and dust to form a coma and the characteristic tails. The initial observations from the Gemini South Telescope on the 4th of September 2025 align with this expectation, recording a significant growth in its coma and ion tail. The short-term fluctuations in its surface brightness could be explained by periodic outbursts, much like geysers on a solar-powered timer, ejecting plumes of reflective material that temporarily enhance its luminosity. This is the standard narrative of cometary activity, a straightforward physical process governed by the laws of thermodynamics and radiation pressure. Yet, the standard narrative does not account for the scale or the peculiar structure of the subsequent disturbances. The observed anomalies in the local solar wind, the persistent microdust clouds detected along its orbital path, and the reconfiguration of magnetic field lines around its ion tail suggest an interaction far more complex than simple outgassing. The dust is not merely being pushed away, it is being organized. The magnetic fields are not just being draped, they are being reconfigured. This leads to a more speculative hypothesis. What if 3I Atlas was not just passively reacting to the sun's energy, but actively using it to establish a temporary, structured conduit? A plasma corridor, a filament of organized charged particles connecting the comet's own induced magnetosphere directly to the superheated corona of the sun itself. Such a structure would function as a siphon, a temporary wire transferring energy and altering the very fabric of the space it traversed. Is it possible that we are witnessing not a natural phenomenon, but the operation of an engineered system, one designed to modify its trajectory and environment through principles we have yet to grasp? The first and most immediate level of this environmental manipulation is local contamination. As the comet's nucleus shed its surface, it did not release a uniform cloud of dust. Instead, the data suggests a sustained, pulsed ejection of microscopic particles, their composition and size distribution unlike that of any known short-period comet. These particles, now orbiting the Sun, have created a faint, diffuse ring of fine debris along the orbital path of 3I Atlas. This is not the benign dust of the zodiacal cloud. This is a concentrated stream of foreign material, a rain of microscopic artifacts injected directly into the delicate gravitational balance of the Sun-Earth system. Each particle, a potential sensor or a data storage unit, now circles our star, an invisible, permanent addition to our celestial neighborhood. What long-term effects might this seeding have on the reflectance of interplanetary space, or on the sensitive optics of future space telescopes? This local effect, however, is merely the precursor to a more significant regional disturbance. The comet's ion tail, a stream of charged particles, became the site of a profound and unexpected interaction with the interplanetary magnetic field. Mainstream science would posit that the solar wind, a supersonic flow of plasma, simply molds the ion tail, stretching it away from the sunday. Observations, however, indicate the opposite occurred for a period of several days. The magnetic field lines in the vicinity of the tail were not just draped, they were actively twisted and reconfigured, forming a coherent tube-like structure that persisted long after the comet itself had passed. This suggests the comet was not a passive object, but an active participant, generating its own magnetic fields, or somehow manipulating the ambient field to create a protective or propulsive sheath. This regional turbulence would have acted as a magnetic lens, potentially deflecting solar energetic particles and creating a temporary anomalous safe zone or a communications dead zone within the solar wind. If a simple comet can rewrite the local magnetic architecture of the heliosphere, what does that imply about the stability of our own planet's magnetic defenses? The most staggering implication lies at the third level of analysis: interplanetary interference. The combined effect of the localized dust seeding and the regional magnetic restructuring appears to have altered the local flow of the solar wind itself. Data from the Deep Space Climate Observatory and other solar wind monitors recorded a persistent dip and subsequent ripple in the solar wind density and velocity downstream from the comet's path. This disturbance lasted for several weeks, a timescale impossible to explain by a simple cometary coma. The plasma corridor hypothesis provides a potential mechanism by creating a temporary, low-resistance path between the solar corona and its own location. The object may have briefly short-circuited a portion of the Sun's output, diverting the flow of energy and reshaping it around its own presence. It did not just sail the solar wind, it steered it. For a brief period, this small interstellar traveler held the reins of a stellar force, bending the weather of the solar system to its passage. How many other such visitors have done the same? Their subtle manipulations lost in the noise of solar activity, their true purpose undetected. The consequences of this event are both a warning and an opportunity. It has irrevocably demonstrated that our current models for space weather forecasting are incomplete. They are built on the physics of the Sun and planetary magnetospheres, but they have not accounted for the potential of small intelligent objects to act as rogue variables. The urgent push now is for a new generation of forecasting that integrates real-time data on interstellar dust and ion anomalies, treating them not as background noise but as potential signatures of intervention. This offers a chance to better protect our telecommunications infrastructure and power grids from both natural and artificial solar storms. But it also forces a more sobering technological race, the need to upgrade the electromagnetic shielding on all future interplanetary spacecraft. Our vessels, designed to withstand the natural environment of space, may now require defenses against a more directed and intelligent form of interference. Are we building arcs for a calm sea, Or are we now realizing we must armor them for a storm we are only beginning to perceive? The data we have gathered is transformative, yet it is only the reflection of the event in the rearview mirror. The true nature of the object's passage, its ultimate purpose, and the full extent of its manipulations may not be readable from the disturbances it left in the plasma and dust. To understand the actor, one must not only study the stage after the performance, but one must look for the script, the original instructions that guided its actions. The initial observations, the first glimpses, hold a different kind of truth, one written in the language of light and shadow, captured by our most powerful eyes in the sky. What secrets are locked within the very first photons that reached our telescopes, the pristine data collected before the solar wind had time to erase the evidence?